Now the next one here says we're going to have to use our CAS calculator to help draw the graph of each of the following. Give x-axis intercepts and coordinates of turning points. Values of coordinates of turning points to be given to 2 decimal places. So you will need your CAS calculator for this. Let's go and have bring one on up. So again, I'm going to use my Classpad, the sensible choice. Yes, I know that's controversial. Some people like the TI Inspire, but the Classpad, it's just nicer. So let's bring these up. So we'll clear all. We're going to type that first one in, x to the power of 4 minus 125x. And we're going to graph that. And what we'll do is we'll set that to default. Okay, so we can see here on my graph, it's very big. We haven't seen the turning point here. So we're going to need to widen this and broaden this. Now you could also factorize that. I mean, that's a very sensible thing to do. You could factorize that and to try to determine algebraically how big they are. If you're in a rush like me, I tend to just do broad values like this. I reckon be -100 is the Y minimum. And I tend to like to put my scale there to be 1/10 of what that is. So make that 10. Okay, that's still not big enough. Let's go -1,000, 100. That's fine. Okay, so we can see there. I'm just going to move my lovely graph around. Yes, as you can see, we've got this sort of slightly melty looking graph here. So we can see what that looks like. What we'll do is we know one of those x-intercepts is down at 0, 0. We can find the other one here. So if you want to find the other x-intercepts, what we do is we go to analysis, gsolve root, as in square root. We've got 0, 0, and we've got 5, 0. So that's handy for us to know. We've got the 5, 0 there as well. And then what we'll also do, we can also find the turning points. The turning point, we go to minimum. There we go. So I got 3.1498, -295. So what I'm going to do is I'm just going to take a picture of that. Put that in here. We'll shrink this down a bit. And we've got our very lovely graph. Zoom in here. There we go. That's our graph for A. I'll flatten that one. So that is A. We've got our coordinates here. I know that's 5, 0 over there and 0, 0 is there. Great. Now the next one that we need to do, which is x to the power of 4 minus 9x to the power of 3 plus 20x squared. Let's go and have a look at how this friend looks. Oh, well, this one I can shrink up a bit. So we'll go to let's try -50. That's going to be 5. Let's go with 100. 10. I think we'll go. Cool, we can actually make that thinner. We'll go to -3 and we'll go to 7. And we can actually make that thinner as well. So we'll go and make that -10. And we'll make that 50. And we'll do 5. There we go. So there's a very lovely graph. We've got clear x-intercepts there of 0, 4, and 5. And we can find the maximum by going to analysis gsolve maximum. And again, I'm just going to take a picture of that. And we should also find the minimum as well. So what we'll do is I'll just paste this in here. I said paste. There we go. And let's shrink this one down. Oop. And we'll zoom this friend in. flatten you. So this is I, and the minimum, which is that little minimum dip there, and we want the other one. There it is. So we might just have to go down a bit more, 20, and get that minimum. G-solve minimum. 4.55 and negative 5.12. So that is 4.55 negative 5.12. Great. And then K here, we're going to pop this one. This is going to be one of those weird looking graphs where it's only got one x-intercept, because I bet you bottom dollar that that is not factorizable. So let's go and have a look at this, friend. Oh, wow, let's go and have a look at this beautiful looking curve here. Let's see if we can bring it up a bit. 50. Yeah, that'll do. So yeah, we've got this very lovely looking curve. It actually doesn't have a turning point at all. The point of inflection, there's no like real flat parts of this either. So the only things we can mark here would be the y-intercept, which would be at 0, negative 20, and this 2 here. So there's no other flat parts at all. So there's our lovely graph. Oh, no, we don't want that one. We want to take this one. There we go. So yes, not all cubics or quartics have turning points. They, depending on how they're shaped, even though that sort of middle part there kind of looks a bit like it might have a shape, it's not. So this doesn't have a point of inflection as we would normally see it. So there's that.